Since launching this channel where I focus on Linux hardware and distro-specific PC builds, I've had a flood of requests for custom builds tailored to specific operating systems. The most popular by far was Bazzite, so I built the compact console-style budget rig to show that off. The second most requested has been Cachy OS, and today it's finally happening. But unlike the more beginner-friendly Bazzite setup, Cachy OS is a distro tuned for raw performance. Custom kernels, bleeding edge drivers, and all the tweakable power you could want. So this time I'm building a high-end Linux gaming PC designed to match that energy. In this video, I'll walk you through the component selection, a fast-paced build montage, a proper introduction to Cachy OS, and the full installation process. Then we'll get it dialed in, install some games, and see how this custom Linux gaming machine actually performs. Let's jump into it. Hey, I'm CJ, welcome to Lifting Linux, where we open the door to open source. Now, most of the Linux specific builds I've done here have featured parts from a generation or two ago or focused on entirely entry-level budget-friendly hardware, but that's not what we're doing today. Since this build is centered around Cachy OS, a performance-tuned distro with custom bleeding-edge kernels and drivers, I've put together a high-end system to match. As always, I need to mention that Lifting Linux is a small channel. I don't take on corporate sponsorships, and it doesn't bring in much revenue, so I can't just buy new parts for every video. That means everything in today's build comes from my existing hardware pool. But the good news is for this build, it's all current gen and was purchased within the last few months. Still, if I were sourcing parts today, there are a few things I'd probably change, and you'll see those as we go. If you appreciate content like this and want to help bring more Linux-specific hardware reviews and custom builds into the mainstream, take a second to like the video and subscribe. It's a small action, but it makes a big difference in helping this channel grow and reach more of the Linux community. Let's start with the core. This is an all-AMD build powered by the Ryzen 7 9800X3D, still the undisputed king of gaming CPUs. Rumor has it that the 9850X3D might drop next month at CES, but for now, this is the chip on top. For the GPU, I went with the XFX Swift OC Radeon RX 9070 XT, and that decision reflects a larger trend. AMD has shifted focus away from the ultra high-end consumer GPUs. In their own words, the engineering effort and high cost required for the ultra high-end consumer segment are not deemed worthwhile when AI chips offer significantly higher returns and growth potential. And that mindset is already shaping the market. While other companies may dance around it, AMD just came out and said it. Because of that, even a top-tier AMD build like this lands more in the upper mid-range tier of the current landscape. The motherboard is the Asus TUF Gaming B850 Plus Wi-Fi. It gives us great balance of next-gen features without pushing into ridiculous pricing. We get PCIe Gen 5 for the GPU and NVMe slot, 2.5 gigabit Ethernet, Wi-Fi 7, and 20 gigabit USB-C. For RAM, I'm running a 32 gigabyte kit of Orico Raceline Neon DDR5 6000. Orico actually sent me this kit a few months ago, and it's been solid on this platform. Unfortunately, I haven't been able to find this memory listed anywhere lately, so it may have been another casualty of the AI boom. Speaking of which, the SSD is a 2 terabyte Crucial P510 Gen 5 NVMe. I picked it up at Best Buy not long ago, but if you haven't heard, Micron is shutting down its consumer-facing Crucial brand to focus entirely on, yes, AI data center sales. It's a very American capitalist move, follow the money. Ever since the 1919 Dodge V4 decision, corporations have leaned into the idea that shareholder profits come first above employee or customers. And even though that decision doesn't technically hold as precedent ever or anymore, the mindset has stuck around. As a result, with billions being poured into AI infrastructure, companies like NVIDIA and Micron are shifting everything in that direction to chase those massive profits. Anyway, rant over, let's finish out the build. The PSU is the Pure Power 13M from Be Quiet, a 1000 watt unit they sent over along with their light base 500LX case, which I reviewed on my main Elevated Systems channel. Since I already had it in the studio, it made sense to use it here. Now, I did a little digging and some testing suggests this PSU has slightly lower efficiency on the 12 volt rail under high loads, and the Overcurrent protections on the 3.3 volt rail is a bit loose, but for this build, that's not a concern. We're not drawing anything close to 1,000 watts, and we're not using the 600 watt 12 volt high power cable, so everything is well within spec. You'll actually see two different PSUs in the build as I was concurrently doing the Lightbase 500LX review, so while I was using the Be Quiet PSU for that, I had my Montank Century 2 850 watt PSU in this build. As for the case, you voted and the results were clear. When I asked whether this build should use a high airflow case or a dual chamber panoramic setup, airflow won by a landslide. Hyte actually saw that poll and reached out to offer their brand new X50 Air enclosure for the build. Of course, I said yes. They sent over the white version along with 8 matching fans, making Hyte the first brand to directly support lifting Linux with a component specifically sent for a Linux build. And since this is one of the most airflow focused setups I've done recently, I completed the look with the white Thermaltake Peerless Assassin 120 SE Digital. It's a solid cooler and fits this build perfectly. The build came together without any major issues, but before we move on, I've got to take a minute to admire the Hyte X50. Just to be clear, Hyte did send me this case, but they didn't pay me to say anything nice about it. That part I'm happy to do free of charge because honestly, two things jump out right away: the design and the build quality. If you're looking to break away from the sea of basic rectangular boxes or those dual chamber glass wrap fish tank cases that have taken over the market, this is the escape hatch. No hard angles here, all smooth curves with an aesthetic that feels like a modern clean throwback to early 2000 cases like the Alienware Area 51 or the Raid Max Samurai. Those were organic, rounded, and a complete departure from the beige bricks of the 90s. Hyte took that vibe and gave it a sleek, modern upgrade, wrapping the whole chassis in fine mesh steel. Both the left and right panels curve up and over the top of the case and lift off in one piece, opening up the entire interior. The front panel is a single stamped piece of mesh steel. Now, I'm an electronics engineer, not a structural engineer, but stamping regular steel like that without creasing or tearing is hard enough. Doing it with mesh, no idea how I pulled that off. Inside, the design is just and clever. Fan mounts are recessed into the front, right, and bottom sections, so airflow doesn't steal space from the main chamber or block any major components. I went ahead and installed all 8 of the matching fans Hyte sent over because, why not? And they're surprisingly quiet. If it weren't for the Thermalright CPU cooler, which has a sharp, high-pitched noise profile, this case would be nearly silent despite all the mesh. If I were keeping this as a permanent build, which more on that in a bit, I'd probably swap out the air cooler for something quieter. Hyte also went old school with a top-mounted PSU, just like we used to do in the 90s. The PSU doubles as the top exhaust. One build note though, because of the PSU's location, a standard length PCIe power cable likely won't reach all the way down and under to the graphics card. You could just let it dangle from the top, but I used a pair of extension cables for a cleaner look. The only nitpick I have, you gotta tip the case over to access the bottom dust filter. That's really it. All said and done, this is easily my favorite case of 2025. I would love to see Hyte give us a micro ATX version because I'd be all over that one. Okay, with the computer assembled, it's time to install the operating system. To install CachyOS, the first step is downloading it. Head over to CachyOS.org. The OS comes in 2 flavors, a desktop version and one optimized for handheld gaming devices. For this build, we're grabbing the desktop version. Once the ISO is downloaded, I plug a blank USB flash drive in and use Rufus to create a bootable drive. Just select the CachyOS ISO, click start and let it do its thing. While that's burning, I can power up the new PC and jump into the UEFI firmware menu. Here I can make a few quick adjustments. I enabled my RAM, Expo profile, and resizable bar, and more importantly, I disable secure boot and fast boot. I also take a second to tweak my fan curves. I prefer a slow, gradual ramp up for noise control. Once the USB is ready, I plug it into the system, save my UEFI settings, and reboot. If everything's gone to plan, the system boots into CachyOS Live environment, a fully functional desktop running directly from the flash drive. It's great for testing hardware compatibility or just poking around. Unfortunately here, nothing wanted to work for me except the Welcome app, so I wasn't able to change the resolution to make it easier for you all to see, but the installer launched and worked, so I just went with it. And this is where CachyOS sets itself apart from traditional Arch. Now, there is a command line installer available, but it's essentially just a version of the Arch install script, a text-based version of the same GUI installer. For this video, I'm using the GUI, and if you ever installed another Arch-based distro, this will look familiar. CachyOS uses a customized version of the Calamares installer. It's simple and intuitive, but there are still some decisions to make. The first big choice is the bootloader. If you're dual booting, say with Windows or another Linux distro, or using something like a ButterFS file system, go with Grub. But in my case, I'm running CachyOS as the only OS, using a basic file system on modern UEFI only hardware, so I'm going with the simpler and faster systemd boot. Next up are the easy ones. Choose your language, keyboard layout, and location. Then we get to disk partitioning. You've got several options here. Install alongside an existing OS, replace a specific partition, manually partition the drive, or wipe the entire drive and let the installer handle everything, which is the option I'm going with. You'll also be asked to choose a file system. CachyOS offers several, but the main choices for most people will be ButterFS and ext4. ButterFS offers advanced features like compression and snapshotting, which can be super useful if you break something during an update or config changes. Remember, it's still Arch under the hood, but for simplicity and raw performance, I'm going with ext4. Next up is one of the most important parts of the entire process: selecting your desktop environment. This defines your entire user experience, how things look, feel, and function. CachyOS offers a full lineup. You've got KDE Plasma, which is the default, GNOME, XFCE, even the new Cosmic desktop is here. I did a full overview of Cosmic in my last video. And there's even tiling window managers like Sway and Hyperland. If you're coming from something like Ubuntu or Fedora, you might want to stick with GNOME for familiarity. If you're transitioning from Windows, Cinnamon is a good bridge. I'm sticking with the default, Plasma, which also happens to be my favorite. It's modern, lightweight, highly customizable, and has one of the better Wayland implementations available today. That's important for smooth gaming on my FreeSync enabled high refresh rate display. This is really where Linux shines. You can choose one desktop or install a few and try them all. The installer lets you check as many as you want, and you'll be able to pick your session at login screen after you reboot. Just be aware that mixing some desktops might result in overlapping apps or settings, so test carefully if you're going that route. There are also some other optional packages listed at the bottom of that screen. Next, you'll create your user account, set your admin password, and name your computer. Then you'll see a final summary screen with all your choices. Review everything, and when you're ready, hit install. You get one last confirmation letting know you are wiping that drive. Then CachyOS begins its installation process. Once it's done, click Finish to reboot. Now that CachyOS is installed, let's take a look at what you actually get. I'll keep the intro short because the real value here is seeing it in action. CachyOS is basically Arch Linux made practical. It still gives you the rolling release ecosystem, the latest kernels, Mesa updates, GPU driver improvements, and all the flexibility of Pac-Man and the AUR, but without the traditional build-it-yourself Arch install. You get a proper GUI installer, as we just saw, sane defaults, and a system tuned for modern desktops and gaming out of the box. If you've used something like EndeavourOS, this feels like it's in the same family, just more optimized and more performance focused. There are a couple of trade-offs. CachyOS isn't trying to be pure Arch, and it definitely favors newer hardware. And while the install is easy, this isn't designed for absolute beginners. You still need a little Linux common sense when managing updates. If you're already comfortable with a package manager and ready to learn a bit more, this is a great stepping stone into the Arch world. With that said, let's dive into the actual desktop. You're looking at a clean KDE Plasma setup. CachyOS ships with a lightweight modern Plasma configuration that behaves just like it does on Ubuntu or Fedora, but with that Arch freshness underneath. Plasma is fast here, responsive, and looks great at high refresh rates. And since this is Linux, you can theme and tweak it however you want. Now, let's take a look at how you actually install software. The first thing you'll notice is that KDE Discover is not installed by default, and honestly, I think that's a good thing. Discover can be clunky, especially with Flatpak, so CachyOS just leaves it out. Instead, it gives you a few solid tools. First up, the terminal. You get both Alacrity and Console, each running the fish shell with auto-completion and color-coded output. Pacman is the package manager here, and if you're coming from Ubuntu or another Debian-based distro, it does take a little getting used to. For example, updating the system isn't sudo apt update and apt upgrade, it's sudo pacman-syu. Syncs the packages, refreshes the database, and upgrades everything that needs to be. Easy enough once you've done it a few times. You also get full access to the AUR, the Arch user repository, one of Arch's biggest advantages. CachyOS ships with Paru pre-installed, so you can install AUR packages just as easily as repo packages. For example, I use the Phoronix test suite in all my reviews, and instead of pulling it from GitHub and compiling it manually, I can just search for it with Paru and install it in seconds. Now, let's move on to the graphical tools. CachyOS includes its own package manager, which is simple and clean. You'll find it in the Hello app under Install Apps or in the System menu. Here you get curated apps and full repo access, and a one-click system update tool. The best part here is you can actually uncheck packages you don't want updated, useful for avoiding breakage on rolling release systems. I've had workloads where updating my custom patched Mesa install would break my entire pipeline. With this GUI, you can avoid those surprises. As far as I know, the CachyOS package manager doesn't expose the AUR. If I'm wrong, somebody let me know, but for that, CachyOS includes Octopi. It taps into Pacman and Paru under the hood and lets you browse both repo and AUR packages graphically. I don't personally use Octopi much, but a lot of Arch users I know tell me it's good for browsing and installing packages, but stick to Pacman or the CachyOS package manager for system updates. Now, if you want something closer to a full software center, something like Discover or GNOME Software, I recommend installing Bao. It unifies repo packages, the AUR, Flatpaks, app images, and even snaps if you somehow hate yourself. Each package source is color-coded, so if I want something like Spotify, I can choose the AUR version or the Flatpak version right from the same interface. Super clean, super intuitive. Under the hood, we're running bleeding edge everything. My install came with the CachyOS 6.18 kernel built just 6 days before I installed it. Mesa is 25.3.1. My AMD GPU drivers are only 3 days old. Plasma is completely current. That's the beauty of rolling release tuned for hardware like this. Everything is fresh. All right, now that we've got the OS installed, configured, and ready to roll, let's see what this system can actually do. Time to test it. I've already installed Steam, Manglehut, and all my benchmarking tools. Everything's good to go, so let's run some tests. Starting with raw system performance in Geekbench 6, the Ryzen 7 9800X 3D scored 3506 in single core, which is about 5% above the average for this chip, and 19459 in multi-core, which is about 6% higher than average. Not bad at all, especially considering I haven't done any system tuning, no undervolting, no overclocking, just stock settings with some smart defaults and whatever magic CachyOS is cooking up under the hood. As always, I've linked the full set of results from my benchmark suite down in the description if you want to take a deeper dive, but let's talk about gaming performance. Looking at native 1440p running mostly ultra presets with no upscaling enabled, we see that all 10 of the modern AAA titles tested deliver very playable performance, each averaging over 60 frames per second. Again, this is native resolution with ultra graphics. If you're chasing ultra smooth 120 FPS gameplay at 1440p, you'll either need to dial back the graphics settings a bit or turn on some form of FSR. We'll get to that in a moment. What really stood out here isn't just the raw frame rates, it's the tight gap between average FPS and 1% lows. Apart from Monster Hunter Wilds and more noticeably Stellar Blade, which both feature heavy use of locally rendered cutscenes, the frame pacing across titles was excellent. If we exclude CS2 from the average, since that one was tested at 1080p, we're looking at 1% low drop of just 24% across the remaining 9 titles. Now, That's borderline, but still very respectable for this hardware and workload. If we remove the two outliers, Monster Hunter and Stellar Blade, that average 1% drops below 18%, which I'd call excellent for consistent frame pacing and smooth, responsive gameplay. That level of consistency is partly thanks to the 9800X3D itself. It's a beast of a gaming CPU, but it's also being pushed even farther by CachyOS. Under the hood, CachyOS ships with a performance-optimized kernel featuring the Bohr scheduler, which is designed for better responsiveness under variable CPU loads, perfect for gaming, combined with other patches for CPU frequency scaling, improved I/O latency, and a system tuned to prioritize foreground tasks. You're getting low latency input and more consistent frame times without needing to manually tweak anything. We see the same trend in 4K gaming. You do need to lower settings in most titles and enable FSR, but I try to balance that carefully. Personally, I'd rather drop the native graphics settings a bit than push FSR past quality preset. Even so, FSR, while not perfect, typically introduce some frame pacing inconsistencies. But here I was surprised. With CachyOS, even with FSR enabled, frame pacing remained tight and gameplay stayed buttery smooth. Now, let's take a closer look at some of the extras modern GPUs and systems bring to the table. Upscaling, frame generation, and ray tracing. These features are often heavily dependent on driver support, so I was especially curious how the open source Mesa drivers would handle them on this setup. To test things out, I picked a handful of games and turned on some of these features, either to try to push performance into that 120 to 144 FPS sweet spot at 1440p, or to get a feel for how well ray tracing actually works on AMD under Linux. Starting with Space Marine 2, performance was already solid over 90 FPS at native 1440p. With ultra settings, just enabling FSR at the quality setting bumped the average up to about 144 FPS. That's a 55% increase with only a minor dip in 1% lows. The gameplay felt smooth and responsive throughout. Expedition 33 uses TSR, that's Unreal Engine 5's temporal super resolution, which, while known for excellent image quality, is also heavier on the GPU than FSR. Even at 50% internal resolution scale, I wasn't able to hit 120 FPS, topping out at around 115 on average. But the important thing here is consistency. Both native and upscaled runs showed exactly the same 18% drop from average FPS to 1% lows. That kind of pacing consistency makes a big difference. You don't feel like you're dropping frames, even if you're not quite at your target frame rate. Same story in Cyberpunk 2077. With FSR quality enabled, performance jumped. With 1% lows, dipped slightly in percentage terms, going from a 14% drop to an 18% drop, but in real-world gameplay, it felt smooth. I also tested ray tracing using the medium preset with FSR bumped down to balanced. While I'll be honest, I didn't love the way it looks objectively, the gameplay held up. It stayed fast and the frame pacing remained surprisingly stable. In Black Myth Wukong, I set the render scale at about 85% and enabled frame generation. Now, frame gen can introduce latency and wreck frame pacing, especially on systems not tuned for it. And while I can't really speak to latency because, let's face it, my old man reflexes are much bigger limiter than a few extra microseconds of input lag, the pacing was rock solid. With FSR and frame gen enabled, the 1% lows only dipped 2% below the average. That's incredible consistency. The same was mostly true with ray tracing enabled. I'll say it again, low RT settings often look worse than just sticking to good raster lighting, but gameplay was still smooth. I did notice a little micro stutter here and there, but nothing game breaking. Doom: The Dark Ages was one title where things get more complicated. This game uses full hardware accelerated ray tracing by default, and while the RX 9070 XT handled it far better than I expected, especially compared to my first test of this game a few months ago, getting to that 120 FPS target required a bit of graphics tuning. I had to drop the high settings and use FSR balanced. Even then, this is the only game where frame pacing clearly took a hit, with the 1% loads dipping 27% below the average compared to 19% at native. It's still very playable, but the difference is noticeable. Now, the big takeaway from all of that is that I didn't run into any weird Mesa-related bugs, glitches, or graphical anomalies. Not a single driver crash, no stuttering caused by shader compilation, no weird Vulkan translation issues. Everything just worked exactly as it would using the Windows Adrenaline drivers. Now, I didn't do a direct Windows comparison in this video because proper cross-platform testing takes a lot more time. You've got to log every single frame time to a CSV file on both systems, then run those logs to a third-party analyzer to get something close to apples, or at least Honeycrisp to Evercrisp apples. And this video already is long enough, but I do have a follow-up coming where I'll be comparing this system running Windows 11, CachyOS, and a few other Linux distros side by side. So if you're curious how this system stacks up across platforms, make sure you're subscribed for that. Anyway, we got to wrap this up, but before we go, we need to address the elephant in the room. This PC, as built, cost over $2,300, and that's a high-end price tag for what's really an upper mid-tier system. For that kind of money, here at the edge of 2026, I want a rig that can do native 1440p at 120 FPS across the board. But the reality is, this is the highest end graphics card AMD currently makes. To push beyond this, I'd have to hand NVIDIA over $1,000 for a RTX 5080. And while NVIDIA's open source driver support is improving, there's still an inherent performance degradation on Linux compared to Windows. So with AMD stepping away from the ultra high-end GPU market, this right here, well, this is what top tier Linux gaming looks like now. And this is what it cost. Still, this entire build is a lot cheaper than just an RTX 5090 alone, so I mean, there's that. But cost aside, if you're looking for an operating system that isn't quietly feeding your desktop actively to an AI assistant, mining metadata, or piping ads into your start menu, then you want something like CachyOS. It's a distro that stays out of your way, focuses on performance, and makes Arch more accessible without sacrificing what makes Arch great in the first place. After using CachyOS for a couple of weeks, running benchmarks, playing games, and daily driving it, honestly, this has been the smoothest Linux benchmarking experience I've ever had. No weird bugs, no surprises, no workarounds needed. Everything just worked, and because of that, I've decided to keep this rig exactly as built, maybe a cooler swap, and make it my new standard Linux GPU test bench. A lot of you recommended I try CachyOS for that, but I always thought vanilla Arch was the better standardized testing platform, and while that's still technically true, CachyOS saved me time. I didn't need to tweak anything, and the benchmark results were more consistent run to run than what I usually get on Windows. Bottom line, time is money, baby. CachyOS is it. All right, I know this was a long one, but that's kind of the point. I don't crank out content every week just to feed the algorithm. I post about once a month here on Lifting Linux, and when I do, it's because I've got something worth showing you. No filler, no shortcuts, just real testing and useful info. So if you found this video valuable, or if you want to see more deep dive Linux builds like this, hit that like button and consider subscribing to help support the channel. Thanks for watching, and I'll see you in the next one.